Hi to all. Welcome back to the video session on tools for real-time data processing and analytics. This is again Sharmila here. So the unit 1 in the last video I have covered the first 4 topics, and in this video I'll be covering the fifth topic, that's the introducing the big data technology landscape and analytics platform. So the overview of this video is I'll be talking about the overview of big data, real-time and stream processing, infrastructure of big data, components of big data ecosystem, analytics architecture, distributed batch processing, distributed databases, that's not no SQL. So in terms of overview of big data, modern organizations generate enormous amounts of data every second. For example, if we take ourselves right from morning, right, when the moment we wake up, right, if we take individual a human being alone, right, for example, I may start the day with an WhatsApp, right, then I may post a message, I may update my status, or I may receive a message, right. So in that case someone else has sent me a data. In case of posting a message, I am generating data. I may send an email, right. If I'm wearing any wearable device, from that some data gets generated, right. I may check an email, or I may check my LinkedIn or my Facebook. So from the moment I start, right, for the day, I may start with a mobile phone by watching the WhatsApp, or by watching my email ID, what is a new email that's come, right, from the individual one person, for example, right, from me itself. Huge amount of data gets generated. Now think around the world. So enormous amount of data gets generated every second. So this data originates how? What are the devices used? Is mostly mobile phones, right, and through websites, IoT devices, sensors, banking systems, healthcare applications, and all other applications you can put forward, and social media. These are the major data generators. That's why I have mentioned here. So traditional databases cannot efficiently process its massive amount of data, and that too, it is continuously getting generated, right? That is the reason big data technology is required. And also, the data, sometimes if a data gets generated, it has to be immediately processed. For example, in case of weather report, right, it has to be immediately processed, right. For example, if you are if FT1 mark or FT2 marks, it may not be generated now, right. It can be generated later on, right, because those marks are aggregated and put as internal marks, right. So that may not be done immediately. So all these are some of the data requirements where real time immediate data generation, immediate real reporting has to be taken out, right. So those are the major components of big data analytics. So instead of storing the data for later analysis, real time systems process the data immediately and after it is generated, enabling instant decisions. So basically, what is data? Data refers to raw facts, numbers, text, images, videos, or sensor readings that can be processed to obtain a meaningful information. Especially, we want all these raw facts to be converted into dashboard. That is analytics, right? So if you could see student marks, temperature readings, bank transactions, GPS locations, social media posts, all these are where your data gets generated as raw facts and then converted in terms of your meaningful databases. So what is big data? Big data refers to huge amount, too large, too fast, too complex data for handling. So big data is a collection of, there are 3 types of basically data as they structured, semi-structured and unstructured data. So that requires specialized tools and techniques for storage, processing and analysis. Let us see what is example for structured. Structured as a fixed rows and columns, declared types, easiest to give a query with the traditional software, especially if you see Excel, CSV, right? Both these are structured data. Whereas if it's semi-structured, means no strict schema is there, but tags or keys impose partial organization. So JSON, XML files, all this belongs to semi-structured. If we say unstructured, no fixed schema at all and needs specialized tools to extract meaning. For example, image, video, audio, all these are free text, right? Any free text emails and then voice recordings, everything belongs to unstructured. The next very important, the big data dimensional paradigm, right? There are 5 V's are there: the volume, velocity, variety, veracity, and value. Volume, as the way I said, enormous amount of quantity, large, huge amount of quantity of data. right? Who generate in petabytes, not tera. Now it has reached petabyte, right? So Google, Netflix, Facebook, everybody generates huge volume of data. The next is with what speed data gets generated, transmitted, or processed. For example, sensors transmit the data in seconds. Variety, types, as we see in the previous slide. So structured, unstructured, and semi-structured is there. Based on that, variety of data comes in. Veracity is nothing but integrity. That means how the data can be trustworthy. So quality, reliability, and trustworthiness of data is what is meant by veracity. So bad data is equal to bad decisions, require screening and validation. Value means insights. So if any of the data is there, seeing that as a data rather than that, we have to see that as an insight, right? If you see as an insights, for example, in a showable way, then very easily we can able to understand the data. So the ultimate goal is convert the data into meaningful knowledge. So what is the traditional data processing methods are there? One is your traditional processing, another is your big data processing is there. What does you mean by traditional processing? It supports only small data set. It will be a centralized database, low scalability, limited storage, batch processing. Like batch in the sense with a group of data and records it gets processed. Whereas big data processing is very large data set, distributed. There's no server client. In case of centralized is a server client technology, but there's no such technology available in your big data. High scalability, distributed storage, batch, and real time. Both are possible in your big data processing. So what is your real-time data processing? So if you want to say your real-time, let us see what is that. Real-time data processing is the continuous processing of data immediately, right? There's no without any delay. For example, few seconds, milliseconds only the delay is allowed. Immediately we have to generate the data. Immediately we have to take a decision and make a report on it. We cannot wait for hours together, right? So example is credit card fraud detection. The moment the card has been misused, the call has come from the customer. The bank has to take the step immediately by closing the credibility of the card, right? And the Google Map traffic updates, immediate updates are happening. Because of that only we can able to get the traffic of all the routes available on the flow. You can see that orange, red color, right? All those are based because of Google Maps traffic updates, immediate updates. Weather monitoring, online stock trading, smart traffic signals, and hospital patient monitoring. This hospital patient monitoring may be used in such a case that so that based on the patients, nurses can be allocated for those particular ward in a hospital. So all these are applications of real time data processing. So what is batch processing versus real time? Batch processing is processes stored data. It processes live data real time. High latency is allowed, not low latency. That means within few seconds you have to complete. It is suitable for reports. It is suitable for instant decisions. Example payroll, whereas example here is ATM transaction. Let us see some real-time example for your real-time processing. You assume SRM as a RFID or biometric attendance. In case of student is not there, I'm just giving an example here. So when a student taps the ID card or biometric device, attendance is recorded immediately and becomes available to the faculty or ERP with a minimal delay. If that gets generated, we no need to call you in the class alone with the register number or with the name, and then we spend around 10 to 15 minutes in that. So that will be avoided. And SRM ERP attendance updates, students can monitor their attendance through the ERP portal and after faculty updates, providing the timely, immediate transaction happens. Right, the admission advisor or your academic advisor does it. Then online fee payment confirmation, immediately you require a receipt. Library RFID book issue, the once you return back the book, it's updated. Wi-Fi authentication, students receive immediate access after successful login authentication. Parking access using RFID. Here we have a Credi app right away, right, in SRM, so that we use for parking especially the two-wheelers. And bus GPS tracking, maybe very soon it will be coming up in SRM buses. Learning management system, we have this e-curricula, right, where all the lecture materials and lab materials have been uploaded, where you can the students can lively, they can able to open the labs and then work upon. So all these some of the real-time processing examples with respect to within a university. For example, that's what I have been put up here. And similarly, what is the example for batch processing, right? So the end semester result processing doesn't happen immediately. So for example, first your FT1, FT2, FT3, FT4, LLT happens, then internal marks get generated, then use it for the exam, then your external marks get generated, both put together only your final end semester result will be passed and your CGPA will be calculated. The next is monthly salary processing, salary for the faculty based on month, because they may be on leave some days, they may be on OD some days, or whatsoever. It has been calculated based on that. Hostel fee report, yearly once only you will pay. Student attendance shortage report, that will be taken for a month wise. Library overdue report, this also will be done as a semester wise. Placement statistics, this will be done only during third year, final year starting, or probably third year ending. The ones they finish the exams, right? Only those times this placement statistics will be kicked off. Then academic performance analysis, department wise pass percentage and topper list are prepared, and after results are declared. So all these are batch processing. That means batch. You calculate. I mean, you collect all the data. Don't process it immediately, but afterwards you process it based on the requirement. Hope you could have got an idea for real-time processing and batch processing. Right. So this is a small classroom activity, like everyone of you can able to use it out, whether it is batch or real time. Just try to fill this column values for batch real, and also with your knowledge, whatever tools can be used for this, also you can find it out. We have seen this in the first class itself. What are the real time tools available? Based on that, you can pick up some tools and put up here, or you can search for latest tools available for each of these activities. So what are the advantages and applications in terms of real-time data processing? Immediate decision making, right? Immediately we can take a decision. Faster customer service, continuous monitoring, reduced operational delays, because the moment we said the real time, minimal delay, right? Latency is very minimal. Improved business intelligence, obviously, right? We are now all living in a fast world. And then if you say applications, banking, healthcare, IoT, smart cities, transportation, manufacturing, retail, cybersecurity, education, everywhere it has been, this real-time data processing is used. Now, let us see what is an event. Now we have seen what is a batch processing, what is a real-time processing. Let us see what is the event. Fundamentals of event streaming. So, event is an occurrence or action that generates data. For example, I open my mobile, I open the app WhatsApp, I post a message, or I update my status. That becomes data generation, right? So, a customer places an online order. That's a data example for event. A student logs into Moodle. Moodle is actually a student curricular platform, right? Mostly it is used, and in your SRM University we use e-curricula. A vehicle crosses a toll gate, a temperature sensor records a reading. All these are occurrence of actions that generates data, and this is all an event. Basically, event streaming is a continuous flow of events. That means per day, maybe I may not put only one WhatsApp message, right? I may continuously put some messages or read the message whatsoever, right? It happens. That's how flow of events happens continuously. In case of WhatsApp message, your Snapchat, or your Insta, then in online banking, GPS tracking, IoT sensor networks, in all these places, event streaming happens continuously. So components of event streaming, very important. There are 4 components is there. One is producer, consumer, message broker, and topic. Producer is generates data. Example, your app, mobile app, temperature sensor, ATM machine. Consumer is consumer receives the data and processes the data. Example, your dashboard, where it processes and gives a report, no? Machine learning application database. In between this producer and consumer, we have a message broker. So the broker stores and distributes the message between the producer and the consumer. That's why we have seen Apache Kafka, RabbitMQ, ActiveMQ as an introduction in the real-time processing. That means in the first video. The next is topic. A topic is a logical category where messages are stored. On what topic, right? We have to see what is, if there are multiple events are happening, what is a topic? For example, temperature is the topic. In that, what all temperature we have calculated from morning till night. Traffic, how much traffic updates has happened, orders, payments, etc. These are called as topic. So the fourth thing you have to remember, if you could see the consumer, right? Producer, consumer, message broker, and topic. What is a message queue, or why is a message queue? So if you could see the 4 components whatever you have seen up may generate a message queue. It is because continuously the producer may start sending the message, and the consumer has to receive it via your message broker on various topics. There may not be only one topic, on various topics. The same producer may generate on various topics also, maybe two, three topics also is possible. So that's the reason it should be the message queues, whatever is formed because of all these four components, should be loose coupling, it should be scalable, it should be reliable, it should have high throughput, and it should be fault tolerance. Because if any such fault, the data is lost, data loss will happen, which is intolerable, which cannot be accepted at all. So this is what I'm going to cover in the first part of the video for the fifth topic, right, which is your the fifth topic in this part of video. The remaining topics where I'm going to talk about the big data will be covered in the next video. Thank you all.